Welcome to the new integrated Qlik Cloud experience for Qlik AutoML. AutoML is Qlik's automated machine learning platform, built directly into Qlik Sense on the Qlik Cloud to allow for seamless end-to-end machine learning capabilities without needing to write a single line of code. Our journey today begins in the Qlik Sense Data Manager, where we can easily connect to a variety of cloud and on-premise disparate data sources that are quickly joined together using Qlik's proprietary associative engine, discovering all the relationships that may exist between our data sources and removing the time-consuming and limiting process of writing SQL-based joins to combine this disparate information. After quickly composing our data model thanks to Qlik's associative engine, we are able to faster than ever before build the flat table that brings together all the components that make up our machine learning problem. Today, we are trying to solve and better understand what is driving customer churn. This not only includes which customers are likely to churn in the future, but as you'll see shortly, why those customers are likely to churn, and what historically has been contributing to high or low retention among current and past customers. Our target today is one of three core problem types that Qlik AutoML can help quickly build a model for: binary or two possible outcomes such as yes or no, true or false, followed by multi-class or categorical where there are more than two possible outcomes, and finally regression or numerical targets on a continuous scale such as lifetime value or sales and demand forecasting. The dataset we'll use today is aggregated at the customer level, and the data model that Qlik's associative engine helped us compose allows us to look at a complete picture of information such as the plan type a customer is on, how much they pay for that plan, aggregated usage and service metrics, and of course our target: will this customer churn within the next 60 days, yes or no? With this historical data, we'll return to our Qlik Cloud Hub and begin a new ML or machine learning experiment by clicking the green Add New button in the upper right corner. We'll be prompted to provide a name, select a space in which to save our experiment, enter a description if desired, and optionally add any tags, then hit Create. We'll now be able to select the dataset we previously built and save to our Qlik Cloud data catalog, and then begin configuring our experiment. By selecting the target on the left, we've told Qlik AutoML what type of use case we're trying to solve for, and AutoML will begin taking a series of steps to best prepare our dataset for model training. For example, we can see two columns that were automatically excluded from our experiment. One for high cardinality because it contained too many unique values, and another that was a constant throughout the dataset. In the configuration panel on the right, we can expand sections to learn more about other time-saving selections and steps that Qlik AutoML has taken for us automatically. This includes selecting a list of appropriate algorithms to test on our dataset, based on use case type and dataset size, the ability to enable automatic hyperparameter optimization, as well as a series of pre-processing steps to best prepare our dataset for model training. Within these steps are the imputation of nulls, encoding categorical features, scaling numerical features, as well as two important steps to help validate the performance of the model that we train. First, an automatic holdout of 20% of our dataset is set aside so that we may test how well the model performs on data that it has not seen before. Second, we'll randomly divide the remaining 80% of our dataset in order to test how well the model performs on 5 random splits to ensure that we get consistent results rather than a model that may perform well on one segment of data but not on others. Having reviewed our experiment configurations, we'll begin model training by selecting the green Run Experiment button in the bottom right corner. You'll see Qlik AutoML begin to work through the previously reviewed pre-processing steps, and then move into training the algorithms we saw selected within our experiment configuration. Results will be presented as they are completed, and once all algorithms have been trained, we'll see a recommendation made by the platform and indicated by a trophy icon in the table. This recommendation is based on the F1 score for classification models or the R² for a regression model. We may explore additional model metrics by selecting the respective columns in our model metrics table. as well as toggle through each algorithm that we may want to review by clicking on the respective row. Below the model metrics table, the first two charts we'll see give us insight into model feature importance. The first chart, or permutation important, indicates how much the model relies on a particular feature overall. The second, or SHAP importance, is calculated at the row level and provides row-level interpretation into how each prediction is made. The chart is an aggregation of these row-level explainability metrics. We also see a ROC curve and a confusion matrix to help interpret how well the model is able to distinguish between our two classes, as well as what the prediction distribution and accuracy look like when applied to our holdout dataset. By clicking just a few buttons, we're able to deploy our model into the Qlik Cloud Hub and start making predictions, including a hosted API endpoint for real-time predictions that may be integrated anywhere. With these predicted datasets added to our Qlik Cloud data catalog, we may quickly add them to an existing data model and begin building apps with integrated predicted and prescriptive insights. As an example of a few insights we may glean from this new data provided by Qlik AutoML, we may create scatter plots of the SHAP values or row-level interpretation in the dataset. If we think back to our feature importance chart from earlier, we remember that the plan type and base fee were two of our top features, but it didn't tell us which plans or base fee amounts were drivers of high or low retention. Using the SHAP values, we can quickly see that the red plan is a significant driver of churn, whereas the blue plan is fairly neutral, and the green and purple plans tend to decrease the risk of churn. Similarly, we can glean that base fees above 40 significantly increase the risk of churn. We may also embed the ability to interact with the model directly into our new and existing apps. As we look through a list of accounts, we see one that has now been scored at elevated risk of churn. We may select this account and get a breakdown from the model of why exactly it scored the risk of churn as it did. We see that the number one factor increasing risk of churn is the plan type. So now we can move to the right and begin interacting in real time to run scenarios on how certain changes would affect the prediction. As we change the plan type to the blue plan, we see a new prediction returned in real time, telling us that the change would result in a significant reduction in the likelihood to churn. Finally, we use the same real-time integration with our Qlik AutoML to power visualizations in our app. The heat map shown here helps us find the optimal combination of plan type and base fee adjustments to reduce the risk of churn and still leave room for revenue growth. And just like on the previous page, we can make changes in real time and see new predictions and simulations to help us understand what best course of action to take. We hope that you found this walkthrough of the Qlik AutoML platform helpful, and we look forward to discussing how it can help shape the future of your analytics roadmap.